Okay, so I have some images in here. I just discovered Midjourney, so this is a freaking game changer for presentations. Okay, so anyway, a lot of the prompts and things like that, you'll see what sort of twisted AI stuff comes up. All right, anyway. So, okay, we did a little introduction. I'll do a little more. So who is this guy? Okay, so like we mentioned, I'm a guy who works at Finicity, a MasterCard company. Okay. I kind of consider myself a JavaScript old hand. I'm pretty proud that I ran IO.js in production. A lot of people don't even know what that is. Yeah, there we go. Okay. So when I come from kind of like C++, it came from C++, came from Flash, other places like that. But when my first introduction to JavaScript, I was like, this is the most garbage thing in the world. I cannot believe this runs the world. But I actually love it now. It's my favorite language by far. And so it's really just like the world's longest case of Stockholm syndrome, I think. But oh, and then you know how when you're building slides, you're like, you put in placeholder content. This might be this. But anyway, I thought my fish died and then it came back to life. This is every bit as miraculous as it sounds. I think I forgot to feed it this morning though, so I don't know. Anyway, okay. So let's go over the agenda. So you can look at this agenda. You hate it. There's another talk that might be better. Okay. So we'll talk about what is WebAssembly, why and when you would use it, and then how to use it, right? We're going to cover the whole stack of WebAssembly top to bottom. Compiling from a high-level language. We'll talk about the text format. We'll talk about the actual binary format. And then how do we actually use that from a JavaScript program? Okay. So I hope I can deliver on my my commitment here, top to bottom. Okay. So what is it? WebAssembly, if you ever see a space between the web and assembly, you know that person doesn't know what they're talking about. I bring that up because I made that typo in my my talk blurb. So anyway, it's WebAssembly, one word. Okay, you'll see it abbreviated WASM a lot of places. Really what it is it's just this, it's a new language, a binary format, right? It runs on a stack-based virtual machine. This is one of the coolest features about it, right? It's a portable compilation target for a lot of different languages. We'll touch on that a little bit. And this is kind of a big deal. It's the fourth language in your browser. It's baked in, right? So we have JavaScript, we have CSS, we have HTML, and now we have WebAssembly, which is really cool. The other thing that's nice is it's really supported anywhere you care about, right? These are the browsers you care. There's a noticeable red box there, but anyway. The point is, yes, you can use WebAssembly right now in the browser. Okay, so let's cover some of the characteristics. So I don't know, I guess Midjourney thought it was fast and open based on this slide. But anyway, it is fast, it is open. Okay, so WebAssembly had a few design goals in mind. One of them was speed, and not even just like top speed, but consistent performance. That's really important for any sort of like customer-facing application. And it's also open. And what do I mean by that? So like the design is open, just like JavaScript. There's a standards committee that handles it. But then also JavaScript is really cool because you can go to any website and you can kind of peek under the cover and see what's going on there. You can do the same thing with WebAssembly, right? Websites, a lot of them do now, right? Like they'll load up some nice crypto miner in the background, right? And so you can poke in there. You can look around, you can debug it and see what's going on. Okay, it's portable. Actually, I'll skip to this next part to talk about this. So it's part of the web, it's portable, and it's not part of the web. And this is actually, I think, the fastest growing segment of WebAssembly. I didn't really see this coming, but WebAssembly has so many use cases, and we'll cover those in a second, that are not even in the browser. So a lot of the community you'll see is using Rust. That's the most popular compiled WebAssembly language, actually. So systems engineers, things like that. Okay, and it's also fun because since WebAssembly is not used on the web a lot, right? It's not web, right? And it's not even really assembly if you look at it. So it's neither web nor assembly. So it's a good name. I mean, just like JavaScript, it's neither Java nor a scripting language, right? So it's good. They match. Okay, so how's it actually being used? this is how I've used it, right? Web development. So this is all sorts of websites. So Figma is one, and I mean Figma's pretty nice. Like you use it. They have some really good blog posts. I have it in the resources here, but they initially built their whole editor out, custom renderer, built on ASM.js. It's moved to WebAssembly now. But I mean, these guys just made a lot of money off of this little web editor. I don't know. Anyway, so that's an example. Serverless. So this is kind of cool use case for WebAssembly as well. And I think the talks will probably touch on this throughout the day. You can use WebAssembly at the edge, other places like that. It's a very interesting space because you can instantiate WebAssembly very, very cheaply, and it's secure. It does all of these things that you'd want it to do. Okay, so Cloudflare Workers is an example. Containerization, like WebAssembly is coming up at KubeCon, places like this. And probably the most important thing is games, right? I don't know. I have a soft spot for games. They're super cool. The thing that blew me away, though, is I expected to see tons of games using WebAssembly. And we have some, but I think it's basically a monetization problem with the web more than it is a problem with WebAssembly. But yeah, it's being used all over the place, which is really, really cool. Okay, building stuff. Okay. I don't know if this is like a 1950s era inspired picture or not, but I don't know. Anyway, so building stuff with WebAssembly. How do we do that? Well, you can compile from a high-level language, and these are some of them. There's so many that compile to WebAssembly now, which is pretty cool. So Rust is the most popular one. AssemblyScript, which we'll be using today. This is a language designed to compile to WebAssembly. C#, that's gained a lot of popularity. C++, that's kind of like the OG WebAssembly target language. Python, Go, Zig, this is kind of a fun language if you're poking around. Anyway, a lot of these languages will compile very efficiently to WebAssembly. So let's talk a little bit about AssemblyScript. Okay, AssemblyScript this is a cool language. So here, let me just skip over these. So what it is it's basically someone took TypeScript, right? WebAssembly was coming out, and all these people were like, how can we build an efficient language for this? And there's Turbo, and there's all sorts of other things that people were playing around with. I don't know who came up with this idea, but someone was like, well, let's just take TypeScript and make it compile to WebAssembly. And that's really what this is. So it's a subset of TypeScript with some stuff added on. So it's a variant of TypeScript, I guess. But you can use your same tools. You'll instantly be familiar with AssemblyScript, and I'll show you some of that. Okay, so if I want to set up an AssemblyScript project, I've got all the steps you need right here. Okay, so npm install. So just with npm, super, super easy. You save your AssemblyScript. You run the init, right? We run init, and then we're going to get this scaffold that it'll build out for us. I don't know if you get. Oh yeah, you can see it. Okay, so it's pretty cool. So we're going to get like our source files. We're going to get all of our build files, which include the debugs, the wrapper.js files. We can see the WASM files in there. We can see the text files. All of that stuff. It's just going to scaffold out right for you. Okay, and then if we run as-build, it'll actually compile it for us. So, it's not really new, right? Like JavaScript, you've been compiling anyway for a long time. But then we start it up. It'll start up a web server for us. So super, super simple to use AssemblyScript. It has a lot of tools built right in, a great website, a good community. So really easy to get into. So let's look at some of this. Okay, so this is, maybe the code is bad. I wrote the code, but you can see like this just looks at like TypeScript, right? Like you might not even be able to tell the difference if it weren't for a couple of weird things in there, right? Like you'll see this I32 thing in there. And other than that though, it looks exactly like TypeScript, which is really nice. So WebAssembly has a few different types. In JavaScript, you're used to, and TypeScript, you're used to really fancy stuff like objects. You're used to, I don't know, fancy things like strings. Okay, WebAssembly doesn't have any of that. Okay, you have like a handful of number types, and that's all that you have. Okay, so you have this is a signed 32-bit integer, right? You have a signed 64-bit integer, unsigned. You have floats. That's all that you've got. Okay. Okay, let's dig in a little more. Okay, so if I wanted to write an assembly script function, this is a really simple function, but this is just add. Okay, and we'll use this example throughout. Okay, so really easy. You could look at that, no extra training, you would know exactly what's going on there. Okay, so that's high-level building with assembly script. Okay, next, let's look at the text representation. So the text, it's not, sometimes you hear it be called an intermediate step, but really all it is it's a one-to-one mapping from the binary file so that humans can read it. So, one-to-one map. And it's called .wat. It was .wast, but I don't know who came up with this. So .wat. I don't know. Anyway, I guess someone said we have a really good feature here, a really good spec. People are going to be excited about how can we make it worse, and so they decided to name it .wat. Anyway, this is the text representation of WebAssembly. So let's look at it really quickly, though. So this is our add function. This isn't compiled. This is just handwritten. But if you compiled from assembly script, you'd see something very, very similar. They're going to add. They're going to add some like pathing to it and some metadata to make it a little bit nicer. But this is totally readable, right? So it has an unfortunate amount of parentheses in here, but if you wanted to, you could completely code this, by hand, and it's fine. So you can see there's this module. Everything's a module, so you'll see this wrapper around everything. But then this function declaration. We have an export on here. That's really just a handle so that when we export our WebAssembly function, you can access it from JavaScript. So this thing's called add. We can see that it accepts two 32-bit integers. It returns a 32-bit integer, right? And then we can actually see the operation that happens here too, right? We pull out our first parameter, we pull out our second parameter, we add them together. That's the add function, okay? All right, so some tooling around WebAssembly, around WAT files. You're going to want to get this WebAssembly Toolkit for VS Code. I still use Atom for like markdown files, but I don't think I've met anyone that uses anything besides VS Code nowadays. But anyway, this is really nice. It's going to give you syntax highlighting for your WAT files, all those kind of things. It'll even allow you to turn a WASM file into a WAT file that you can read. And there's also this thing called Wabbit, which is where you get this Wabbit from. So then what it is it's the WebAssembly binary toolkit. And this has a lot of stuff in there. It's really nice for working with the low-level things in WebAssembly, but the one that I'd like to call out here is WAT to WASM. So you can hand code stuff, compile it into a WASM file, and use it. Okay, so let's look at what the actual binary looks like. So it's really compact, which is nice. So JavaScript, not so much, right? It's a text format. It's compact, so even after you do your compression and things like that, you're going to come out on the winning side on a WebAssembly file with some caveats, right? Like if you compile from a garbage collected language or something like that, you're going to have to compile a lot of runtime features in because WebAssembly doesn't have a garbage collector yet. Anyway, there's gotchas with anything, but it's really compact. And it's super fast to parse. In fact, it's you can stream it and parse it at the same time. Okay, a much simpler language than JavaScript is. And the browsers can cache it really easily. So your WebAssembly applications, when they load up, the second load is pretty close to instant. All of this stuff is cached. Okay, so what does the binary look like? Well, I don't know what you guys were expecting. But anyway, you want to pump out a binary file, it's going to look like this. Okay, so maybe the only notable thing in here is you see the format has some header information and things like that. But then you can see our export for add is actually called out there. Okay, so now how do we use these in JavaScript? Okay, this would be amazing. It's crossed out. This would be amazing if you could do this. Okay, if you could just say import foo from my WASM module. There's a proposal to do that, but you can't do that. Okay, so what you do is you need to load the data, you need to instantiate the module, get a reference to the module exports. Okay, then you're in business. That sounds like a lot. It's actually pretty easy, which is outlined here. Okay, so there's in the browser anyway, you have this whole WebAssembly API. And maybe the most important function in there is instantiate streaming. So you can see I'm just fetching, I return the promise, I instantiate the WebAssembly module, grab the exports, and then I'm in business, I can use it. The other thing that's really, really cool about this is WebAssembly is all run synchronously with JavaScript, right? So it's not like you have to await a promise. There'd be a lot of overhead with that anyway if you want to do that, but it's just like you're using JavaScript code. So this is going to be amazing when we can actually import modules just like JavaScript. Anything written in other language. There's so many cool C++ libraries out there. You're going to be able to do all of that stuff as if it's JavaScript code. Okay, but wait, there's more. I think Steve Jobs actually said one more thing. Okay. Anyway, this was supposed to be Steve Jobs presenting the iChicken, but I don't know. I don't know what it is. Okay. So I wrote. We have 2 minutes. We have enough time. Okay. So I wrote a little a benchmark here, and I was going to put some graphics. Anyway, let me explain. So you're going to see some chickens on the screen, which is normal for benchmarks. Okay. So different colored. Basically, I just wrote what algorithm? Oh, just a function that finds primes, does it a bunch of times, right? So it's just eating up CPU. But wrote it in JavaScript, wrote it in C, wrote it in AssemblyScript, compiled them, and then they all run in separate threads. And you'll see the chickens move around, and based on how fast they move, that's how fast the code is running. Okay, down to 2 minutes. So let me mirror this really quick. Okay, hold on. I have to do a little bit of juggling here. Okay, hold on. Oh, it's glitching. Hold on. Okay. So you can. Don't be distracted by the other stuff. Just look at the chickens. Okay, so now a couple of things here. You might say, Paul, okay, chickens are like the worst way to benchmark something. And I would agree with that. Okay, but now the other thing you're going to say is these chickens all appear to be moving at about the same speed, which is also true. So I think there's lessons to be learned here. One, benchmarking is a really hard thing to do. Okay. So as much as I would have liked to come up here and have the red and the blue chicken zipping around, that's just not the reality, right? Because JavaScript is actually really good at these micro benchmarks. A ton of optimization has gone into these JavaScript VMs. So they're actually pretty fast. They're running all at about the same speed. There's a little bit of overhead calling into WebAssembly as well, which kind of counts against it in these micro benchmarks. Okay, anyway, this is for sale. So come talk to me. Okay. This is like a real benchmark someone wrote. They wrote a Game Boy emulator, which is pretty cool, and then they went back and rewrote it in AssemblyScript to see if they could get some performance gains. And I ran these earlier, right? Your mileage may vary, but it's kind of cool to see, right? So you can see WebAssembly, highest FPS, then we moved to the TypeScript version, about half that. So that, at least on my computer, they about doubled their frame rate for this program. This is like a real program, right? Okay, and even more importantly, it's really stable, right? The performance is stable in WebAssembly versus JavaScript or TypeScript. Okay, I'm out of time. Hold on. Okay, so close the deal, land the sale. Okay, that's where we are. Okay, so WebAssembly is pretty great. You know how to use it now. See me about Chicken Mark. And WebAssembly, there's so much to research. Maybe take a screenshot of this. I don't know. Awesome, exciting field. Okay, that's it.